Alrighty, welcome back everybody. It's your main math Mr. Shank coming to you live from Summit Academy. In this video, working on that Unit 7 practice test, talking about everything right triangles, whether it's the Pythagorean theorem or the trig functions that we've been using. But for number 1, it says, what are the side lengths of the sides labeled A and B on the triangle below? So since it gives us an angle inside of the triangle, that kind of tells us it's going to be a trig function. So what I can do is I'm going to say, okay, let me label my sides. So I'm going to say, okay, here's my right angle. Across from that is my hypotenuse h. So that 15 times that square root of 2, that's going to be labeled h. And then what I can do is I can pick an angle, and I'm going to say, well, this angle inside is going to be my angle theta. It's going to be my angle theta. Across from that is going to be side opposite, and my side next to my angle is going to be side adjacent. So just be careful when you're labeling your sides and picking your ratios, because you want to make sure that you are setting them up with labels first. Alright, so we're going to do our labels first. Now, again, I'm going to use this picture twice because I have to solve for A and B, or side opposite and side adjacent. So just make sure that you're setting them carefully. So for example, if I'm looking at these two sides, I would say, well, I have O and H, so I'd say I'm going to pick sine first. So I'm going to say, okay, I'm going to say sine theta equals opposite over hypotenuse. I pick my ratio. Again, I can cover up my side that I didn't use, or erase the side that I didn't use, because I'm saying, okay, I have O and H, and then I pick my ratio. So now I substitute in my values for my variables. So I say, okay, I still have sine. My angle is 45, so I'm going to say theta is 45. Side opposite is A, and H is 15 square root of 2. You got to be careful with that one too. You want to make sure you're making sure it's carefully written out. Alright, so now that we have our ratio set up, I need to use my inverse operations to get A by itself, or solve for A. So for this one, all I have to do, really simply, is just multiply both sides by that denominator. So for this one, actually move, let's see if I can move this over. Actually, I'll just multiply it out. I'm going to say, okay, I'm going to multiply both sides by 15 square root of 2. 15 square root 2. Multiply both sides of that by that, because I'm trying to get A by itself. So now I have A equals 15 square root 2 and sine 45. And you want to be careful of that, because a lot of people, what they're going to try to do is they're going to try to extend that square root symbol out. So make sure you don't do that. Make sure it ends at that 2, because it's only square root of 2. So when we multiply this out, this is just one number. So now I can pull up my Desmos calculator. So let me do that right now. So there's my Desmos calculator. And I need to type in what I am looking for. So actually before that, since we're talking about solving for our trig ratios and we're working with our right triangles, first thing you need to do is make sure you change your calculator to degrees. So I'm going to go up here to the graph settings, or that little wrench in the top right. I'm going to click on that, and I'm going to change it to degrees. And so now I have my calculator in degrees, so I can calculate what I need. All right, so I'm looking for A, and we said, let me go back one second. We said that was 15 times square root of 2 times sine 45. So let's type that in. So I'm going to say 15 square root, so I can go down, square root. I'm going to say, okay, square root of 2. And notice where my cursor's at. So inside the square root symbol, or the radical symbol, is where my cursor is. So I have to hit to the right, because I need to multiply it by sine. So I'm going to say, okay, now sine of 45. And you'll notice that's going to be 15. So that's okay. Even though it's a crazy looking number at first, we're going to say that's equal to 15. And that makes sense, because if I'm thinking about my right triangle here, let me do this. If I'm thinking about my right triangle, I have to have a number that is less than 15 times square root of 2. So I have to have a number that is less than that, because my hypotenuse is the longest side. So I'm going to just say A equals 15 for that one, and be good. All right, similar idea. Let's do maybe yellow. Split it up here. All right, so now I'm going to be solving for b, and I don't have to change my picture at all because I already have my sides labeled. So now I'm going to say, okay, well, I have a and h for my trig ratio, so I'm going to say cosine of theta equals a divided by h, or adjacent divided by hypotenuse. And so I say the same thing. I say my cosine of 45 equals b over 15 square root 2. Same first step as before, multiply both sides by the denominator. Always multiply both sides by the denominator, so I multiply both sides by 15 square root 2. 15 square root 2. And now I'm going to say, okay, bring this down. I'm going to say b equals, actually move it up a little bit more. Let's say b equals 15 square root 2 and sine, oh, I've got to have myself cosine 45. All right, so let's type that into Desmos now. And let's pull this up. And let's type that into Desmos. And actually, since I already have this in here, I can say, well, let me just change this part. I can change this trig function to just cosine. So I can save myself some time. Again, notice how it looks very similar to the setup as before, but also too, it's equal to 15 as well. And that's okay because we needed a side that is less than 15 square root 2. All right, so we're going to say our answer for B is also 15. So again, make sure you set up your right triangle, label your sides, pick your ratio, substitute, solve. All right. So now moving on, number 2, it says what are the lengths of the sides of the triangle labeled E and D? You may express your answers in simplest radical form or decimal approximation. So for us, what we're going to just do is we'll just get our round comma 2 since we can get some decimals. All right, so same thing. Let's find our right angle. So here's our right angle in the triangle, 90 degrees. Across from that is going to be our hypotenuse h. Again, we can pick either angle, either 30 or 60. Our answers might look a little bit different, but again, it's really simple because as long as we pick an angle and stick with it, we'll be okay. So I'm going to say, hey, this is my angle theta, which is 60. Across from that is going to be side opposite. And so that makes our side of 13, that's going to be adjacent. All right. So again, now if you want to pick one or the other, you certainly can. Let's just do h first since that one's a little bit different. That one's a little harder because when we're solving for the hypotenuse, it's a little bit more difficult, meaning we just have to do one more step. That's okay. So if I'm solving for h, I need to have a value for a. I could use sine if I knew what e was, but I don't know what it is, so I have to use cosine instead since I have a and h. So I'm going to say, all right, cosine theta equals a divided by h. Substitute my values in. So I'm going to say cosine 60 equals 13 over d, because d is going to be our hypotenuse for this problem. And so just like before, I said I had to multiply both sides by the denominator, so I'm going to multiply both sides by d. So multiply both sides by the denominator. On my right side, it cancels out. The 13 comes down. And on my left side, I have d times cosine 60. Okay, I'll sneeze there. All right, so let's do, it says d cosine 60 equals, and again, the numerator denominator cancel out, so the 13 comes down. All right, so I can't say this is my answer because I don't have d equals numbers. I have one more step. So now we divide by cosine 60 because we're trying to get d by itself. So I say cosine 60 divided by cosine 60. So now I say d equals 13 divided by cosine 60. Again, that's the number of cosine 60 is one number. So if you want to, if you don't like doing these steps, you can essentially switch out where D and cosine 60 are, and you'll get your answer the same way. But I like to show my steps one piece at a time. All right, so I'm still in degrees, so now I'm going to type in my answer for D. So let me clear out what I had from before, since we're a different problem. I'm going to say, okay, 13 divided by cosine, C-O-S, cosine of 60. That's going to be 26, okay. That makes sense because I needed a number that is going to be more than that leg, because I'm looking for the hypotenuse. So I can say that makes sense because my leg was 13. The leg that we had was 13. So I'm going to say, since my hypotenuse is more than that, that is a good sign. So I'm going to say, okay, D equals 26. Okay, so my hypotenuse is now 26. Okay, so that's a good start. So now I need to solve for E now. I need to solve for E. And E is side opposite. So what I suggest you do is you use that side adjacent again because that's a given number. So we can use tangent for this one. So I'm going to say, all right, I have tangent theta equals opposite divided by adjacent. So I can say, all right, I have tan of 60 equals E divided by 13. This one's a little bit easier too, since we are just multiplying both sides by that denominator. It's going to be just one step. So multiply both sides by 13 to just show your work. And so we're going to say E equals 13 tangent of 60. Let's see what that looks like in our calculator. All right, so let me clear this out. We said 13 tangent 60. And if you notice, we get a decimal form here. What I suggest you do is round comma 2 so you can get 2 decimal places. So what I'm going to do is I'm going to click on my answer. Just click on my answer once. And I can say, okay, Control C to copy. And then what I'm going to do is I'm going to type out round, because I need to round, parentheses, Control V to paste, and inside the parentheses, comma 2. So make sure you're using that form like I showed you. Again, your answer is pasted in here, but inside the parentheses, that key part is comma 2, because notice how it gives me 2 decimal places. If I wanted 1 decimal place, I would say comma 1. If I wanted 3 decimal places, I would say comma 3, 4, so on and so forth. But for us, we just need 2. So now I'm going to say my answer for my answer for E is going to be 22.52. So let me write that down. So I'm going to say E equals 22.52. And that makes sense because if we said our hypotenuse was 26, that means that our side length E has to be less than that. Okay, so now moving on to number 3, to study the triangle and solve for x. So if I notice how the only angle I have inside of the triangle is a right angle. That means that I'm not going to be using my trig functions or my trigonometry ratios. This tells me I'm going to use my Pythagorean theorem. So I have to kind of remember and use those posters from before, but I'm going to say my Pythagorean theorem. Again, only works for those right triangles, but we're saying that's just a squared plus b squared equals c squared. Again, please do not say a2, b2. We are saying a to the power 2, or a times itself plus b times itself. And we're getting those right triangles down. All right, so like we had before, again, make sure you find your right angle inside or across from your right angle. I should say across from your right angle. You're going to label that as h, which is your hypotenuse. Or we can say, actually, let's label that as c, because that's our hypotenuse c. And then our other 2 legs are just a and b. Again, those don't matter as much because Again, those two are legs. The important part is that hypotenuse C. So now I have my equation first, so I'm going to say a squared plus b squared equals c squared. I'm going to substitute my values in for my variables. So I say I have 60 squared plus x squared equals 65 squared. And so I should get a number that is less than 65. Since I know my hypotenuse is 65, that tells me that my legs have to be less than 65. So let's pull up that calculator, be able to get those values down. So let me clear out some of these. So I'm going to say, what was our, I already forgot, 60. Yeah, so we're going to say 60 squared is 3,600, but we also had 65 squared is 4,225. Okay, so pick that value. So we're going to say, okay, 60 squared was, let me double check. Okay, we're going to say 3,600 plus, we don't know what x squared is, so that bring that down, and 65 squared was 4,225. Okay, so when you're solving for a leg, you have to subtract because we have a two-step equation here. We have to get x by itself. So I'm going to subtract 3,600 from both sides. 3,600. I subtract that out, and I say, okay, the x squared comes down, and then I have, was it 625 as my subtraction? So if I notice, hey, I can't say this is my answer because I know it has to be less than the hypotenuse, which is currently not. And that makes sense too because I need to have x equals something. All right, so now what I have to do is I have to take the square root. That's the opposite of squaring something, or that's how you get rid of an exponent, is you take the root of something. So I'm going to say square root of 625. If you want to pull that up in your calculator, you certainly can. So I'm going to say in my calculator, I can say, let me clear this out. I said square root of 625, and it's equal to 25. Again, make sure you type it in very carefully, find it one piece at a time. So now I have my answer. I'm just going to say x equals 25. And that makes sense because that number is less than my hypotenuse, and I know good. All right, moving on to number 4. Now it has same kind of setup, and it actually gives us a multiple choice, so you have to pick one of those answers. Alright, so since it gives us a multiple choice answer, again, we always have to pick one of these choices, either A, B, C, or D, but we can show our work and prove that it is this answer. So again, like I said before, since we don't have an angle inside of the triangle, we can't use our trig functions, but what we can use is, since we have two sides, we can figure out what our missing leg is. So I'm going to say, okay, across from my right angle is C, and then I can label my two sides as A and B and my two legs. Alright, so I'm going to say Pythagorean theorem. I'm going to say is a squared plus b squared equals c squared. Simple as before. Again, be careful in those decimals. Let's say, and plug in those decimals. So I say I have x squared plus 0.3 squared, or 0.30 squared, equals, and then we have 0.35 squared. So we're going to say, okay, let's go to our calculator, be able to simplify what those values are. I'm going to say, okay, cancel that one out. All right, so we said first we have 0.30 squared is 0.9, and we had 0.35 squared is that number. What I suggest you do is we round at the very end. I always suggest rounding at the very end, so whatever values you have, just take down for now, and then always round at the very end. So let me take these values back over to our answers. So let me write this down quick. So we said, okay, we have x squared is still the same, plus 0.09. Let me double check that one. Yep, and we have equals 0.1225. Let me double check that one as well. Yes, okay. So now that we have these two, again, I could subtract. So I'm going to subtract 0.1225 0.09 from both sides, because I'm trying to get that x by itself. Try that a little bit better. Let's do this and that, and make sure it's still on the screen. Yep, okay. So I have x squared equals, let me double check that value. So I have 0.1225. Let me show you what I'm doing real quick. Don't miss a thing. Minus 0.09. Okay, 0.0325. Okay, just want to make sure I got that down. All right, so x squared equals 0.0325. Triple check. I like to always make sure I'm double checking my answers as I'm working with decimal, just because it can get a little rough. What I'm going to do, I'm going to bring this up just so I have a little bit more space, but as long as you guys are in the same step, you guys are good. Okay. So there's what we have so far. If you're thinking about it, this is a little bit of a weird one just because right now I do have a smaller side than my hypotenuse, but I know I have to have x equals a number, so I can't have x squared equals a number because this is not my answer. And also too, actually, this is a good reason to look at your choices, because if I think, hey, I have an answer that's less than my hypotenuse, but if I look at my answer choices, none of them are close. So I know I have to do something here. So what I'm going to do, take square root of both sides to be able to get rid of that exponent. So I'm going to say, all right, take a square root. Let me pull up my calculator again. All right, so now I'm going to say, get rid of some of this. I'm actually going to take a square root of this number, so I'm going to copy, type in SQRT, or I'm going to hit the square root button, paste my number in. There's my value. And if I want to, like I said before, I looked at my answers and all my answers in second decimal place, so I'm going to say round, parentheses, paste, comma, 2. And I could say, hey, it's about 0.18. So I'm going to go back to my workspace here. And I'm going to say, okay, I said x, write this down, I said x equals 0.18, which we're going to say is our answer because that is going to be B. So make sure, like I said before, that you're at least picking one answer when you have a multiple choice answer question. Okay, moving on to number 5 now. It says study the rectangle. What is the perimeter and area of the rectangle? So it's a little bit different, but this is really just a review from middle school, because we can use those same ideas that we had from before, from middle school, where we found the area and the perimeter of a rectangle, but we can also solve for those missing sides using that Pythagorean theorem or using those trig functions. And I'll give you a hint, since we have that angle inside the triangle, that I see that 25 degrees there, that kind of tells me, hey, that's probably going to be my trig function. So what I'm going to do, I'm going to label my sides here. So I'm going to say, okay, here's my right angle. Across from that is going to be my hypotenuse. I'm going to say, okay, here is my angle theta. My angle theta is 25 degrees. Across from that is going to be my side opposite. And then that means that the side on top here is going to be A, which that's going to be the side I'm going to label as X, because that's the side I need to solve for. So I suggest being able to figure out your side, because if I found my hypotenuse, that's not going to really help me find my area or my perimeter, where if I find an outside length, that should be exactly what I need. So I'm going to say that side A is what we need to solve for. So I'm going to say, okay, well, my two sides I'm going to use are opposite and adjacent, so that means I'm going to use tangents. I'm going to say, okay, I'm going to say tangent of theta equals opposite over adjacent. I'm going to say tangent of 25 degrees, because that's my angle. Make sure you guys see what I see. Okay. 25 degrees equals opposite, which is 5, over x, which is A. All right. So since x is in the denominator, we're going to have two steps here, but it's the same first step as before. Multiply both sides by that denominator, the bottom of a fraction. Multiply both sides by x. On the right side, it cancels out. So I bring it down. I'm going to say x times tangent 25 equals 5. And so now I can get x by itself by dividing by tangent 25. So I divide both sides, tan 25, tangent 25. Let's go to our calculator. I'm going to say x equals, and I'm probably going to round my answer here because for the most part I don't need to round the other ones, but I'm going to say, okay, let's pull up my calculator, clear out my other things here. I'm going to say, okay, I had, what was it, 5 divided by tangent, so tan of 25. There's our answer. What I suggest you do is round that answer, so I'm going to click on it, Control C to copy, and I say round parentheses, paste comma 2. Okay, so let's say it's about 10.72. This is okay, even though this isn't our final answer. That's okay. I just want to round it so that way I can get a nice decimal answer here. All right, so I'm going to say, undo this one. I'll say x is about 10.72. My notes here. Yeah. So I'm going to say, okay, x is 10.72. That's after I rounded it, so make sure you are rounding it. All right. I'm not circling. Notice I'm not circling this as my answer because this is not my perimeter or my area. But what we can do now is we say if this is 10.72, if you think about your area is really easy to find because all we have to do is we say, okay, area equals length. Let's actually just write it out. Let's say length times width, which is just those two side lengths. So I can say area equals 5 times 10.72, which if we multiply that out, do it on the calculator real quick. All right, we said parentheses 5 and parentheses 7.72. 10.72 is going to be 53.6. Okay. I'm going to say my area. My area is going to be, what did I say one more time? 53.6. Yeah. 53.6 meters, actually, since we have meters on the side. All right. So that's going to be one answer as our area. Now we need perimeter. Perimeter is going to be equal to, let's say, 2 times the length plus 2 times the width. And you're probably wondering, hey, Mr. Chang, I don't know which one's which. As long as you label one of those sides, or if you just pick one of the sides and you don't use it twice, that will be okay. So for perimeter, I'm going to say it's going to be 2 times, let's say 5, plus 2 times 10.72. So let's type that in. I want to show you what I'm typing in. So I'm going to say for my, okay, so that first one was my area. My second, yeah, let's leave it out. So I'm going to say my perimeter is going to be 2 times 5 plus, again, be very careful where you put those parentheses and those signs and whatnot. And we're going to say 2 parentheses 2 times 10.72. Like that. That's going to be 31.44. And that's going to be our perimeter, meaning the outside amount. I'm going to say perimeter equals 31.44. 31.44. Okay. Another way you could have done perimeter is you could have labeled, I could have labeled, hey, the opposite sides on a rectangle are equal, so I could have labeled this as 10.72 and this is 5, and then added up all the sides and it would have been the same answer, but the way I showed you also still works. All right, moving on to number 6 now. All right, so this is a big problem. I want to make sure you guys take it one piece at a time. This is a competency question, so that means it is a graduation requirement. And so make sure that you are getting at least 3 out of these 4, so that way you guys are good. All right, so for number 6, really simple. It says Zamir needs to determine the height of the building. he has taken all of the measurements shown in the diagram. It says for part A, write an equation or describe a process to determine the height A. And let's solve for height A, round to the nearest tenth. So that's going to be, for that part, we're going to say round, parentheses, answer, comma, 1, because that's going to be one decimal place. Just put a 1 like that, maybe. Okay. So if I look at my little right triangle right here, that one's going to be pretty easy to find because I'm saying, hey, that's height A. I'm going to draw my little triangle here, so I'm going to redraw it for what I need. I need to make it a right triangle. I'll say my hypotenuse is 25, and my bottom is 9. So I'm going to say across from my right angle is C, and then my two side lengths, my two legs are A and B, and we're looking for that side length of, let's actually switch this around so that way it's not as confusing. Let's say A and B. All right, so I use my Pythagorean theorem. Let me actually get rid of this so I have more space to write. I'm going to say I have Pythagorean theorem, so I have a squared plus b squared equals c squared. And I'm going to say, okay, plug in my values. So I don't know what a is, that's what I'm solving for. B squared is 9 squared, and c squared is 25 squared. So be able to simplify, make sure I'm going to say I have a squared plus 81, because that's 9 times 9, and 25 times 25 is 625. Let me actually double check as well, just to be sure that I am good. So I'm saying 9 squared is 81, and 25 squared is 625. So I know I'm good on those two. Okay, easy. Okay. So now, inverse operation, since I'm solving for a leg, I have to subtract both sides. I'm going to subtract both sides by 81. So I'm going to say, okay, a squared equals, I'm going to say 625 minus 81 is 544. That makes sense too, because I need to take it one more step because my answer is not less than 25 because we're solving for a leg. So I need to take a square root. I'm going to say square root of both sides. I'm going to say a equals, and let's say, let me get my calculator out again. So he said square root of 544 is 23 point, and then some decimals. We said to round that answer, let's say copy, it says round, parentheses, paste, comma, 1, because I need one decimal place. So it says 23.3, so that's what we're going to go with. All right. So we're going to say that side length, or that height A, is just going to be, that height A is going to be 23.3. Again, since we are rounding, because it says to round that answer, that's why I'm going to round it there. So keep that in mind. So we're going to say it's 23.3. So if I want to write it here too, I can. 23.3. All right. Either way works. All right. Same kind of idea for part B. We're going to say write an equation or describe the process to determine the height of B, and then solve for the height B, round to the nearest tenth. So same exact idea. I need to be able to solve for this height B. It's a little bit different because we actually have an angle now, so I'm not going to use the Pythagorean theorem. I'm going to use a trig function. So I'm going to draw my little triangle down here so that way I can kind of do it on my own. Let's actually do that a little bit better. Okay, there's my right triangle. I'm going to say 60 is my angle. Let's try that one more time. A little bit better. And 30 feet is going to be my hypotenuse. And I'm saying for height B, which we can label as X right there. to label that as x. Alright, so we drew our triangle. Now I can pick, well, it's actually not before I pick my ratio, I need to label my sides here. Then I say, okay, here's my right angle. Across from my right angle is my side hypotenuse. Let's find our angle inside. That's going to be angle theta. So I say 60 is going to be theta. Across from that is going to be side opposite, which is x. And then that blank side is going to be adjacent since it's next to my angle theta. So since I have O and H, I'm solving for x. I have sine. So I'm going to say, okay, I have sine theta equals O divided by H. Plug in my value. So I say sine of 60 equals x over 30. Really simple because I always multiply by the denominator. So I'm going to multiply both sides by 30 to get x by itself since x is in the numerator. So now I can say x equals 30 sine 60, which let me type into Desmos. Again, still in degrees. Let me pull that up so you guys can see. All right. So we're going to say 30, 30 sine 60. And get my answer, and it says to round the first decimal place. I'm going to copy my answer. I'm going to say round parentheses paste comma 1. So even though I don't have one decimal place, that makes sense because it rounded. It looks at that first decimal place and then it uses the next one to determine if it's rounding. And since it rounds up to the next whole number, it's going to say it's 26. So we're going to just say our side length or our height for B is 26. So we're going to say this is just going to be 26, which is B. So I can say B equals 26. All right. Okay. These numbers are important because we're going to use them in the last part, or sorry, the next part actually, I should say. So in part C now, I'm going to go to the next part on the same picture, but just different question. It says, how tall is the building in feet? Show your steps or explain your thinking. So we said, so let me label some sides here. We said height A was, what was that one more time? We said height A was 23.3, so I can say this is 23.3, it's right here. And we said height B, excuse me, is 26. And we have all the other heights because if we think about it, we're saying that this side length x, which is what we're solving for because it says how tall is the building in feet, we're saying that whole side length is what we're solving for. And if you think about it, this side length is going to be equal to these side lengths added together. So we have that one, and that one. And this makes sense because if you think about that rectangle, that shape that I showed you before in was it number 5, the previous question, we said that those opposite sides are equal on a rectangle. So even though this doesn't make a perfect rectangle, it still has those same shades. So if we add all these heights together, we're going to be okay. So we're going to say this. Let me write it like this. So let's say add heights together to get x. 1 second here. Okay, so now we can add those heights together. So I'm going to say I have 23.3 plus 45.5 plus 26 plus 31.4. And you have to be very careful. You're probably asking, well, what about this 9 and what about this side here? I don't have to worry about those because those are the bottom lengths. So I'm only asking for how tall it is. I'm not asking for how wide it is. I'm going to say how tall it is. And so I can add those numbers together. I'm going to say all together, those are going to be equal to 126.2 feet. That's going to be my height for the building. Okay, which is an important part because we need this part. We need this answer for part C and for answer for part D now. So a little bit tougher question, but we can figure out what to do here. So it says Aiko is standing on the ground 284.4 feet away from the building. She is looking at the top of the building at an angle of elevation of 23 degrees. Aiko claims that she is approximately 5.5 feet tall. Do you agree or disagree with Aiko's claim that she is she is approximately 5.5 feet tall? Explain your answer with mathematical support, meaning show your work. Then it says, hint, it may be helpful to draw a model for the situation. So always draw a picture. All right. So what I suggest we do is draw a little right triangle because we know that's what we're going to be working with. So there's my right triangle. I'm going to say something like this. I'm going to say, okay, this is, let's say the height. Let's say this is the height of the building. Okay. And if you notice how that height went a little bit further because we said Aiko is standing right here. And we're saying that this right here is 5.5 feet tall. We're saying the degrees is 23 degrees. Let me write that a little bit better. 23 degrees inside the triangle. We said we're trying to figure out what this length x is. But we said we know that this height from part C, so this is going to be, this is our answer from part C, which was, what was it, 126.2. We're saying, is this true? So, and then we also had to include this 284.4 away. So we said 284.4 away. So standing that far away from the building, the height of the building is over here. Again, notice how it is that entire amount, and we said it's this amount there. Okay, so what we can do, let's set up our ratio. So we're going to say, here's our, okay, so what we need to do is set up our ratio, set up our triangle here. So I'm going to say across from my right angle is my hypotenuse. Inside my triangle is angle theta, which is 23 degrees. Across from that is my side opposite. And then we're going to say side adjacent is next to it, which is going to be the 284.4. So we're going to say, all right, this is going to be tangent. So I say tangent theta equals opposite over adjacent. Plug in my values. So I say tangent 23 equals x over 284.4. So our one step that we have, multiply both sides by that denominator. So multiply both sides by 284.4. 284.4 on both sides. Keep doing that. There we go. And this is helpful because we're just going to say that x is going to be equal to 284.4 times tangent of 23. And if you notice how we haven't included that 5.5 yet, because we're saying our height h has to be all that plus that 5.5. So we're going to say our height h, let's say this is h, or this as h maybe. Let's say our height, actually I'll leave it as it is because we're looking for our height. So let's say our height is going to be equal to, well, I have to include Aiko's height as well. So I'm going to say 5.5 plus our side for x. So we say 284.4 tangent 23. So what I could do, I'm going to type that all into the calculator and try to get our answer. So let's see what it looks like. I'm going to say 5.5. Let me make sure you guys see what I see. Okay. I'm going to say I have 5.5 plus 284.4 tangent of 23. And if you look, notice how our answer is very similar to our answer from part C. So I can say this is, so let me hide this real quick. So we said this is going to be about, so I'm going to say approximately 126.2, which is our answer from part C that we got from before. So what this means is we have to write a little sentence to summarize what's going on. So we're going to say, yes, we should agree with Aiko's approximate height. Approximate height. Since it is, let me make sure you guys see it. It is, let's say, close to our calculated height in part C, which we said was 126.2, which is similar to the 126.2 that we got in our answer for part D. So make sure you're setting up your pictures carefully and ask questions if you get stuck. And as always, super slam that subscribe button.